Hi everybody, welcome to week 2. Last week we did the functional groups and the bonds present between them. Whilst not really directly accessible, if you don't understand those, you won't be able to understand anything else in this unit. We're going to work on naming today, and what I want you to do is get used to looking at the functional groups and figuring out what they are. The quicker you can do that, the easier this unit will be. There was one question on naming in last year's exam and one question on picking the functional group. So we will look at naming and how all of them are named. You don't really need to know how to name all of them in any great detail, but understanding actually, okay, that's what this name means. When I see this, it should correlate to this name. And the more we use the functional groups, the better off we will be. So we have 12 major functional groups, I think. I can't remember the exact number anymore. And we will go through naming all of them. What will take your teacher 6 weeks, we'll get through in an hour. So the simplest one that we start with, obviously, the alkanes. Bright pink because why? In the chat, how do we name the alkanes, anybody? So we know that we have an alkane when we have no functional group. Scientists are not very creative. They're a very specific bunch of people. So remember, when we name, we're looking at the longest continuous chain of carbon atoms. So if there's one, it starts with meth. If there's 2 carbons, it starts with F. 3 is prot, and 4 is bute. I'm not going to go above those 4, but you would be expected to know up to 8 or even 10. But we're just going to focus on those 4 because it doesn't really change. You just change the name for every carbon. So whilst you copy that down, I'm just going to grab a eraser. So when we're naming the alkanes, we look for the presence or lack thereof of functional group. Nice and easy, an alkane ends in ane. And depending on the number of carbons, here we have 1, 2, 3, prop. So we would call that fluoropropane. Everybody's terrified of naming organic compounds. If you can remember this up to about 8, and you remember the functional groups, it's quite easy because it doesn't change. The way that we do it doesn't change. You just have to be able to pick what functional groups they are. I won't spend too much time on naming or learning them because it is quite a simple process. But what I want you to do is get comfortable with the functional groups. So the next one we look at is the alkenes. We know there's an alkene by the presence of a double bond. And we get rid of a couple hydrogens. Now the reason we have to get rid of hydrogens is each of these lines is a pair of electrons. The octet rule states that the carbon is full in its outer shell when it's surrounded by 8 electrons. If you are drawing molecules in your exam, you will lose marks for putting too many hydrogens in. Happens students I had last year. So this is exactly the same, but we name it propene. So we call it propene. Now, I'm changing the way I do this slide, but I'm going to introduce the concept of an isomer here. So if we look at propene, what this name doesn't tell us is where does the functional group sit on, here it's on carbon number 1. That's really important because if the carbon moves to this position, it's something completely different. The very first thing we do when we name the isomers, and an isomer is a molecule that has exactly the same number of carbons and hydrogens, but the position of the functional group is different. So what we need to do is label the carbons 1, 2, and 3. The reason we name from this side, it's not because we write from left to right, it's because you want this functional group here to have the lowest number possible. So we name the alkenes slightly different. We would name it prop-1-ene. Because if this functional group moved to the second carbon, it would be something completely different, prop-2-ene. So we have when we have alkenes, we have to name them based on where the double bond and which carbon it comes from. In this case, there's 3 carbon atoms. Prop-1 is the position of the functional group, and ene because it's a double bond. Remember the isomers, exactly the same number of carbons and hydrogens, but if we switched the functional group here, we would have prop-2-ene. So the position of the functional group is really, really important. That's why when we're naming alkenes, we name carbon atoms, the position of the double bond, and then we call it ene. If I'm going too quickly, please let me know. The next one is the alkynes. The alkynes are characterized as having a triple bond between the carbons. Again, exactly the same thing as the alkenes. We count the carbon atoms, labeling the carbon in which the functional group comes off as number 1. And we're following the octet rule, I hope, with our hydrogens. This is just prop-2-ene, or prop-1-ene, because the position of the functional group is very, very important. All right. So that's the basic ones, the three basic ones. And I want, when we're doing this, I want you to draw them. I want you to name it. I want you to say why we're naming it. Do it along with me. The more you can introduce yourself to this concept, whilst it won't make up a huge portion of your exam, it'll help everything you do make sense. And it is a couple, if you can understand this, it's a couple of easy marks on your exam as well. Right, so let's go back to, so we have an alkane. So again, I want you guys to get used to using these names. We start with, so our base molecule is ethane. But what I'm going to do is I'm going to add a halogen. So these are our halo alkanes. So alkanes being bromine, iodine, fluorine, and chlorine. And all we do is we add a chlorine molecule. Again, scientists, not very creative. We simply call this chloroether. If you want it to be pedantic, but oh no, we won't. So that's when there's one halogen. If it was bromine, you would call it bromoethane. If it was iodine, you call it iodoethane. If it was fluorine, it'd be called fluoroethane. So we can add 2 halogens. And hopefully I can demystify this, that you just apply the same basic naming rules to all of your, for all of the different organic functional groups. It's all the same stuff. This is where we have to name the number the carbons. I mean, there's only 2 carbons here. So we would call that 1, 2 dichloroethane. So again, we're naming, I mean, it doesn't matter when there's only 2 carbons. I will do one with 3 carbons so you can see that why it does matter. So 1, 2 is the position of the chlorine atoms, of which carbon atoms they come off. Chlorine, the chloro, di because there's 2 of them, and ethane because that's our backbone molecule. Now, if I change this to 3 carbons, the name changes slightly. So if I had chlorine down here, chlorine and bromine, we can use, it's kind of the same idea. It doesn't really matter which end you name from. So we'll go left to right, 1, 2, We know that the backbone molecule here is an alkane and it has 3 carbon atoms. We know we have a bromine off the first carbon. And then we have 3 chlorine. When you're naming anything like this, you put all of the names in alphabetical order. So the name of this would be 1 bromo, 3 chloro, propane. So we name the backbone, an alkane, 3 carbon atoms, a chlorine coming off the 3rd carbon, and a bromine coming off the 1st. Where it would be important which direction you went in would be if you had a molecule like this. So everyone makes the mistake under pressure of counting left to right because that's what we do. But if we counted left to right here, the functional groups wouldn't have the lowest number. So if you named it like that, you would have 2 bromo, 3 chloro, propane. That is incorrect. The classic one, if they do give you an exam question, is a dihaloalkane because they can be true. But if you remember, you count from the end, that gives all of the functional groups the lowest number possible. You can't go wrong. So the correct answer here is actually this one. 2 bromine, 1 chloro, propane. All right, everybody keeping up with me? It's probably the most painful part out of all of it. Sweet. All right, so let's go back to our alkane. So back to our alkane, because that's what everything starts as. So now we're going to look at the alcohol. So we know that the alcohols have a hydroxyl functional group, or OH. Now, you'll remember me saying that scientists are not very creative. I'm just picking a random new alcohol. So when we name an alcohol, we find out, okay, how many carbons has it got? Okay, F. Okay, so it's not just an alkane, so it's not ethane. Okay, we just take the OL off the end and we make it ethyl. So when we're naming alcohols, I wish it was as simple as you just stick an ol on the end. Sometimes it is. But it gets a little bit more complicated. So this is simple. This is what we call a primary alcohol. It's called a primary alcohol. Everybody gets confused. It's called a primary alcohol because the carbon that this attaches to is directly attached to one other carbon. So, or it's always on the end. And we just name them with an element. Super easy. So primary alcohol, the carbon that the hydroxyl group is attached to is only attached to one other carbon. It's not how many carbons are in the chain, but how many carbons is this one here attached to. I'll say it again, scientists, not very creative. So now we're looking at, we create this. So we have now our alcohol, or our hydroxyl functional group, is attached to the middle carbon. And our middle carbon is attached to two other carbons. So you guessed it, this is a secondary alcohol. No, it's shocking, right? And we name them kind of the same, but kind of different as well. So we know it's a secondary alcohol because the carbon that this is hydroxyl group attaches to is attached to two other carbons. And you guessed it, it'll always be in the middle. We name it, so we name the backbone first. Okay, cool, it's 3 carbons. So propane. Now we need to know which carbon this is coming off. The 1. In this case, it doesn't matter which way you go. So we call this propan 2. So when we're naming secondary alcohols, we count the carbons from the end that will give this the lowest number. We name the backbone, so propan 2, and it's an alcohol, so we call it on. I have a feeling we're going to run quite a bit over time. Yes? Okay. So there's one more. We call it, I know, very creative again. Tertiary alcohol. Mind-blowing naming skills. So what we'll get here, and did we talk about methyl group? So when we have a tertiary alcohol, the carbon that this is attached to is attached to 3 other carbons. So this guy here is directly attached to 1, 2, 3 other carbons. Now we name this slightly different. I feel like I should have done this before. We'll go into this after. This guy here is what we call an alkyl side chain. You should have learned about that in grade 11. I think I may have put too much faith in your teachers to teach you about the methyl groups and the ethyl groups. I will go through those after this, and hopefully it makes more sense. But this guy is called an alkyl side chain, and it has a whole separate name to the rest of the molecule. But we name it the same. So in this molecule here, which is like a separate bit, it has 1 carbon, so we would name it methyl. And I'll go through these guys after this. So it's a methyl side chain, and the alcohol is coming off the second carbon. So the methyl group is coming off the second carbon. The alcohol group is also coming off the second carbon. So we have 2-methyl, which is this side chain here. And you know it's a side chain when it's not in a straight line. It's a little side chain of carbons. We name it the same as the rest. 2-methyl tells us there's a methyl group coming off the second carbon. The longest continuous carbon chain is 3 carbons, so we call it propan. The alcohol group's coming off the second carbon, and it's an alcohol, so we call it alcohol. I guess the way that I try to teach this is it's all pretty much the same stuff. You just have to get used to and understand the functional groups and the bits that go on the end for each. It's all pretty logical, and I'll go through that when we go through aldehydes and ketones. Okay, so I'm going to jump backwards a little bit. Your teacher should have taught you about isomers. We did a little bit of isomers with the alkenes, but let's go back to alkanes. I feel like I put too much faith in the teacher. Organic molecules are not always what we call straight chains. This is an alkane, it's in a straight line, it's very boring. In some cases, we get a little rogue carbon chain coming off it. And we vaguely visited isomers in the alkenes. So what this is an alkyl side chain. Now, if you wrote down and you remember meth, eth, prop, and but, we name them exactly the same as we would if there was, as we do the alkanes. The very first thing we do is we find the longest continuous chain of carbon atoms. It's 1, 2, 3, 1, 2, 3. If it's the same, always count in a straight line. So we number the carbons first. 1. So now we've kind of gone backwards back to the alkanes, but we call these alkyl side chains or methyl and ethyl groups. So we treat this as if it's a functional group in itself. So it's got one carbon, so it's methyl. It's coming off the second carbon, so we call it 2-methyl. And the longest continuous carbon chain is 1, 2, 3, so we call it 2-methyl propane. So we name the functional group. In this case, it is the methyl group. We number the carbons. Then we name the parent chain, which is the longest continuous chain. Now I hear you say, what if there's more than one side chain? I have no fear. So now we have 2 side chains. Oh my gosh, what do we do? Well, we take carbon, so they're both coming off carbon. So 2, 2, we name the position of the functional group first. So 2, 2, hey, it's like the dihaloalkanes. There's 2 of these methyl groups, so we call it dimethyl. The longest continuous chain is still 3 carbons. So 2, 2, dimethyl propane. So I'm going to set you a question from a couple of years ago, before we go on to any more complex naming. This one is designed to stump you. Those of you doing chemistry with me have probably seen something similar. I only do everyone. What my point in doing this is, it doesn't matter how complex the molecule might look, you're just sticking the names of a bunch of things together. So I'm going to give you 2 minutes, not 6 minutes, all right, 2 minutes to name this. What is it? I just want you to remember those basic naming principles of the side chains, of the, of the alkenes, and just put it all together in one name. This was an example from a couple of years ago. But the whole point of this is to make it real, like an exam. Go through all the stuff you will be going through in your exam. One minute. If you're feeling brave and you're doing the seminar live, you can put it into the chat. Poppy, just remember the position of the double bond. Yeah, so 2, 2, dimethyl prop 1E. Your teachers will tell you that this is the biggest, hardest, scariest thing you'll ever do, but it's really not. It should be simple, it should be logical. And when you get to your exam, I'm going to make some of these questions, these first 2 weeks, not particularly accessible, so there won't be many questions, but I'm going to make the questions in the coming weeks so hard, by the time you get to your exam, they will be like a walk in the park. I was having a meeting with a teacher from the UK, and he puts some of the stuff in the exam at about a grade 10 level in the UK. So I'm going to push you guys really hard in this. I'm going to give you lots of content. I'm going to do lots of questions. But that means that by the time you get to your exam, the exam should be pretty comfortable for you. My favorite game that we can try and break your spirit with the exam questions in a good way to try and prepare you for what's to come. Okay, so I'm going to give you a quick question, another question with about functional groups from last year's exam. So over this side. I'm going to try and trick you. I'm going to use lines instead of, you see that? Yeah, that's a double bonded oxygen, by the way. So I want you guys to tell me what functional groups are present here. Just to, because I know I don't draw them like this, and they're inconsistent in the exam. They will draw them both with this way and the straight chain way. But each of these points represents a carbon atom. So if I was to draw us 1, 2, 3, 4, 5, that's 1, 2, 3, 4, 5, 6 carbons. So what functional groups are present on this molecule here? You can ignore almost all of it aside from 2 parts. Go back to your notes, find your functional groups, and pick out which ones are there. Okay, so the obvious one here is the alcohol or the hydroxyls. The not so obvious one is this one here. And this is an ester. The reason that I demonstrated like that is I think I drew an ester last week as something like that. So that is equivalent to that. It's just written in a slightly different way. So what I want you to do is start to look at the functional groups and how they're represented on different molecules. But we will go through that now. 6:45. We'll go slightly over time for that. Okay, so let's go back to names. So we start with our alkane. So anybody hazard a guess as to what that functional group is and what this molecule would be? No? So it's a ketone. How do we know it's a ketone? Well, it's got a carbon double bound to oxygen. I'm not expecting you guys to know this already. This takes a bit of time to develop. But it's called a ketone because it's attached to two carbons. So it's a ketone. It's attached to two carbons. When we name them, hey, guess what? It's the same as naming the alkanes. So we've got 1, 2, 3. Propan. And remember what I said, if you remember that scientists are not very creative, we just call it propanone. So if you see something with "one" on the end, it's a ketone. Whoever came up with this stuff made it very simple for us. Now, if we look at an aldehyde, it has exactly the same functional group. But there's one distinct difference. As in the name, aldehyde. The functional group, the carbon, is attached to a hydrogen and a carbon, so we call it an aldehyde. So same functional group, it's just attached to a carbon. Little hack, if you see this on the end, it's an aldehyde. Again, we go back to that very simple naming. Propan, al. If it's an al, you see propanal or something ending in al, you know that it is the functional group for the aldehydes. Let's see if there's any questions from the exams on naming. I don't think there is. It's just one of those things that you need to understand. No. So it's not something that's directly accessible, but the more you understand about how these are named, and the more you understand the functional groups, the better off you'll be. Okay, so now we're getting into the weird ones. So now we're going to do the carboxylic acids. So carboxylic acids, functional group is COOH. So it has this double bonded oxygen, but then on the end it also has OH or CO. And guess what? We name it the same way as others. And again, if you're not 100% sure on the functional groups, don't worry. You're going through them in class, you're going through them here, and just read them until you cry, and then keep reading them. So we name it exactly the same. We have propan. The reason I don't go too in depth into this naming stuff is it's not directly accessible. So any ideas what I will put on the end of propan for a carboxylic acid? Come on, Ross. Don't let me down. No pressure. we would call it propanoic acid. Propanoic acid. It's a carboxylic acid. We name it exactly the same as an alkane. We just add oic acid on the end. All right. Am I making sense? That's the question. So, we're going to learn about, is everybody comfortable with those naming conventions? You don't need to know how to name the rest of these molecules in the slightest. I mean, we could do it, but it's definitely not going to be assessed. So I'm going to take a question from last year that stumped everybody. And we might finish on this one. So you'll notice that I've written this differently again. And most students have a teacher, your teacher will teach you with one way of drawing it. It may be like this with the shorthand, it might be with the lines, with the points on them, or it might be the way that I normally do it, where you draw out the whole molecule. We'll be using all three ways intermittently through this so that you get used to it. So does anyone have any idea what you would call this? It's okay. Not many people in last year's exam had any idea about this. And firstly, because I haven't taught it what you need to know. So what we have here is an isomer. So most alkenes are isomers for a number of reasons. So here we have what is effectively a 3D molecule with both hydrogens on the same side. So if hydrogens are on the same side, we call it a cis isomer. If we did something crazy, if we did something crazy and put the hydrogens on opposite sides, it would be called a trans isomer. Hydrogens on the same side, cis isomer. Hydrogens on different sides, it's a trans isomer. So when we're naming these molecules that look like this, we start the name with cis. We know it's a cis isomer because both are on, both hydrogens are on the same side. Cat just came into the room. Awesome. 2 seconds. So we name this, some weird stuff happens on these recordings. So we name this not by where the carbon is coming off of. We name it where this second chain off the side starts. So we call it trans 2-pentene. Trans because it's, oh sorry, cis 2-pentene, my bad. Cis because it's a cis isomer. 2 because the carbon chain comes off the second carbon there. Sorry, never mind me. 1, 2, 3, 1. So cis 2-pentene. Because the double bond is coming off the second carbon. Cat was very distracted. I think out of 10 students last year, I think that I had only about 4 of them actually got that question right. I actually finished on time. I thought that was going to go way over. Right, does anyone have any questions about naming? Any questions about naming? No? All right, we'll finish that then. So next week we start on boiling point, volatility, melting point. If you can read up on your functional groups, as well as the intermolecular forces that we covered, it'll make your life a lot easier. I will see you guys next week. I'll send out the recording once it's uploaded.